So to introduce fine-tuning classification, I'm going to start with the introduction. Algorithm classification are a type of machine learning method used to categorize data into predefined classes or groups. In the realm of marketing analytics, classification algorithm plays a crucial role in predicting discrete outcomes. For example, they can help predict whether or not a customer will buy a product or whether an email is a spam or not. These algorithms are essential because they help businesses make data-driven decisions, such as targeting the right customers in marketing campaign or detecting fraud in banking. So fine-tuning is a process of optimizing a model to achieve better performance. It involves adjusting parameters like pre-processing data and evaluating performance metrics. This is crucial because a poorly tuned model can lead to inaccurate prediction and limiting its usefulness. So analyzing this chapter helps us address one question: how do we choose the best classification algorithm to solve classification problems? We will introduce two algorithms and talk about different classification, pre-processing data, and evaluation metrics, and then conclude with ROC and AUC to identify the best performing model. So today I'll be talking about some popular classification algorithm in machine learning and why it's important to choose the right one for your problems. We will cover super vector machine, decision tree, and random forest. And I'll also explain why just looking at accuracy isn't enough to properly evaluate a model performance. So choosing the right classification algorithm. When you're working with machine learning, choosing the right algorithm is crucial. There is many options, but each algorithm has its own strengths and weaknesses. For example, SVM, decision trees, and random forest are all used for classification tasks, but they each work in different ways. Knowing how they work and how to fine-tune them can be helpful to get a better result. So super vector matching, also called SVM, is a supervised learning method that tries to find the best boundary or hyperplane to separate different classes of data. The goal is to maximize the margin of the distance between the hyperplane and the nearest data point from each class. A larger margin usually means the model is more reliable. So advantages and disadvantages. Advantages, SVM can be slow when dealing with large dataset, and picking the right kernel and setting the right parameters can be tricky. And the disadvantages is that it can be computationally slow with larger dataset, and selecting the appropriate kernel requires careful tuning, which can be challenging. So another prompt is that no, it's okay. So now decision tree. Decision tree is a simple model that works with splitting the data into smaller parts based on a certain criteria. It's like a flowchart that asks yes or no question at each step. This process continues until it reaches a final decision or prediction at the leaf node. So advantages of decision tree is that they handle both numerical and categorical data. They require minimal pre-processing and are not parametric. They make no assumption about data distribution, and their web box nature allows clear explanation of the decision making process. About disadvantages of decision tree, they are prone to overfitting, especially when grow too deep, capturing noise instead of patterns, struggling with complex and imbalanced data set, and less accurate and they are less accurate compared to ensemble of method like random forest.
To prevent overfighting, you can limit the depth of the tree of use pruning. Random forest is an example method that combines multiple decision trees to improve performance. Each tree is trained on random subsets of data, and when it's time to make a prediction, the model averages the prediction from all trees or use majority voting. Random forest reduces overfighting because it averages the prediction from many trees. It works well with imbalanced and dataset and can handle missing or noisy data. It's harder to interpret compared to decision trees, so it's often seen as a black box. Also, while it reduces variance, it can still have some bias. You can tweak parameters like the number of trees and the depth of each tree to improve performance. Now, why random forest outperform SVM and decision trees? In comparison, random forest shows the best performance with an accuracy of about 81%, while SVM achieved 76% and decision trees 75%. This is because random forest combines multiple decision trees, making the final prediction more accurate and robust. Unlike decision trees, which can overfit the data, random forest reduces this problem and handle more complex data relationship better. Now we're going to talk about why accuracy allows it enough. Why accuracy tell you how often the model prediction are correct. It doesn't tell you the full story. If your dataset is imbalanced, a model could be very good and predicting the majority class, but fail to predict the minority class correctly. This can lead to misleading high accuracy. To get a better understanding of how well your model is actually performing, you should look at other metrics like precision, recall, F1 score, ROC curve. This metric consider how well the model performs on each class, not just the overall accuracy, and they give a clear picture of how the model behaves, especially when the data is imbalanced. So now we're going to talk about the part 2, and this part talk about the turning machine learning model involves improving their performance by adjusting certain parameters. This includes steps like pre-processing data, selecting hyperparameters, and validating the model ability to make accurate prediction on new data. Key techniques include standardization, cross-validation, and random grade search. The first one, standardization, scales all variables to the same range, mean of 0 and standard deviation of 1. This ensures that each variable contributes equally to the model learning process, especially when their values are on very different scales. Without standardization, the model might give more weight to variables with a larger numerical range. The second one is the cross-validation with stratification. Cross-validation evaluates a model's performance by splitting the data into multiple subsets. The model is trained on some folds and tested on others. Stratified key fold cross-validation answer that each subset maintains the same class distribution as the original data, which is particularly important in imbalance classification problems to avoid bias. And the last one, random's grid search. It's an optimized model, hyperparameter, by testing a random sample of parameter combination instead of all possible combination. This reduces computation time while finding effective parameter. For example, this method improves the accuracy of a random forest model to 82.8%, demonstrating its effectiveness in enhancing prediction.
Okay, I'm going to walk through how we evaluated the effectiveness of various classification models in predicting customer churn. We used three key performance metrics: precision, recall, and F1 score. These metrics help us gain a comprehensive understanding of the model's performance. Let's start with precision. Precision for a churn prediction model indicates the proportion of correctly predicted churn cases, true positives, out of all cases predicted as churn. It helped to ensure that when the model predicted a customer would churn, that prediction was likely correct. For example, a precision of 0.79 means that 79% of customers predicted to churn actually did. For recall, the second one, recall, measures how many actual churn cases were successfully identified by the model, representing the proportion of true positives among all actual churn cases. Random forest achieved a recall of around 0.82, meaning it correctly identified 82% of customers who actually churned. This is especially important in churn prediction, as missing a churn customers, false negative, can be costly for businesses in terms of retention efforts. And finally, the F1 score, which balances precision and recall, is crucial when there is a trade-off between minimizing false positives and false negatives. The random forest grid search model achieved an F1 score of 0.81, reflecting a good balance between identifying churn customers while minimizing false alarms. This score ensures that the model not only catches a significant number of churned customers, high recall, but also doesn't identify too many loyal customers as churned, high precision. By using these three metrics, we were able to assess the random forest model's ability to predict customers' churn effectively. Its high scores across precision, recall, and F1 show it's well suited to help businesses identify and retain at-risk customers.
So to conclude, I'm going to talk about the confusion matrix, the ROC, and its corresponding AUC. So the confusion matrix is an important tool for evaluating the performance of the models, especially in classifying customer churn. It visually represents the number of true positives, true negatives, false positives, and false negatives, and it allows to assess how well the model differentiated between customers who churned and those who did not. For example, in the random forest grid search model, the confusion matrix revealed a high number of true positives and true negatives. So the high true positive rate, correctly predicting churn customers, indicate that the model can effectively identify customers at risk of leaving. And this enables the company to proactively target these customers with retention strategies such as personalized offers. And the high true negative rate indicates that the model can effectively identify customers who will not churn and are, let's say, loyal. Therefore, it ensures that the company does not unnecessarily spend resources on customers who are likely to remain loyal. So then for the ROC curve, which is receiver operating characteristic, and its corresponding AUC, which is the area under the curve.
So they both provide further insight into the model's discriminative power. The ROC curve plots the true positive rate against the false positive rate, and a higher curve toward the top left corner indicates a better performance. So the random forest grid search achieved an AUC of 0.82, which was the highest among the models tested. And this suggests that the random forest model had a very good ability to distinguish between churned and non-churned customers, making it the best choice for the marketing team to predict customer churn. So even with slightly lower AUCs, the SVM and decision trees models demonstrate curves that stay well above the diagonal line, which is the random guessing. So it reinforces that all models have a value depending on the company's specific needs, like resource constraints or speed requirements. And also the AUC of 0.82 of the random forest is strong, but not perfect, which means that it leaves room for further optimization, like analyzing misclassified class cases, which are false positives and false negatives, to improve data quality or model features. And we can also tune hyperparameters further or explore ensemble approaches beyond random forests.